This is module 5 and 6 of Kinesiology 200. It's combining both the motor learning and development with this bridge to psychology. Before reading this or listening to this lecture, you should have watched the Quiet Eye video and completed the quiz for the attached video. And the quiz itself was meant to be a low stakes, easy points, just to hold you accountable for the video. Hopefully the video you found entertaining and applicable, that you will use some things from that. So as we move into the motor learning and performance, we're looking at the cognitive processing of the brain. And when it's hard to quantify this, but when you look at the research out there, we look at the human brain quite a bit as a computer. And you see in the background here the zeros and ones, and that's processing data, bits. And everything in the human body is binary in terms of ons and offs, zeros and ones, yes, no, positive, minuses. And that's how all of Mother Nature, all of the universe actually communicates. And when we look at the processing power of the brain, it can process 11 trillion bits of data per second. That's huge. That's enormous. What's interesting, though, and I think you've looked at different sci-fi movies where they say they only use 10% of your brain or 5% of your brain. And if you're able to tap into that, I always think of the movie or TV series Limitless, where they had the drug NDZ, and that was able to tap into other parts of the brain. And that's not necessarily true. We use all of our brain. What happens is that when we look at our conscious thought, out of that 11 trillion bits of data per second, your conscious thought, what you can actually focus on at any given time, is anywhere between 50 to 100 bits per second. That's not a lot. There's this myth within the aspect that there are multitaskers, and there are some people that can process about 120, 130 bits per second. But for you to pay attention to me talking right now, it's taking about 60 to 70 bits per second to focus on what's going on. And you only have now about 30 to 40, maybe 50% of that left in order to focus on something else. Now, some people that can process consciously 130 bits per second, they truly can do two things at once, but that's like 1 out of 100 million different people. So it's not the norm, it's the exception. The norm is somewhere between 50 to 100 bits per second. And if you look at each of these boxes as 10 bits per second, that represents one fraction of one of those boxes. So it's not a lot. And as you saw from the video, or at least you gained from the video, that your conscious mind can control or influence that other 10 trillion, 99.9% of those bits of that information. So in class or on Blackboard, we'd have a discussion of any thoughts, questions, or epiphanies that you had from that video. And I would seed the questions with these 5 aspects of the difference between expert and novice regarding gaze, field, how the gaze affects performance, what you're focusing on to improve performance, your arousal level versus performance. And this is where we start to bridge the gap between motor performance, motor control, and then sports psychology. Are you in a sloth-like or lazy state, or are you in a overstressed state, and that's affecting performance, and then the mental state and performance? So we say, what do you think? What surprised you? The most important question that I'm going to ask you on your discussion boards is, what are you going to do with this information, right? How are you going to use this? Are you going to be a better dart player? Are you going to shoot pool, shooting baskets, shooting hoops, hockey? And what's interesting is that video is about 10 years old now, and we look at the technology. You had this huge headset on, and but what's neat is they have these glasses now that you can wear, and the glasses are these lenses. There's a laser, and it's measuring where the pupil is going. And so they use this technology for sport and performance. They also use it for advertising. They'll put the glasses on, and they'll pay you as a test subject, and they'll show you a show or a screen or a movie clip or whatever, and they want to see where your eyes are going on the screen. So are you focusing more over here, or are you over here? And then they'll ask you some questions. What do you remember from the commercial, or what happened in the show? And so it's neat where that technology is going. The next slide here is showing a video of the progression from going from novice to beginner, or using this quiet eye training. I don't think I'm going to be able to get it to work from within the, so let me exit out of the presentation. I think I have it pulled up here. Let's see if I can get it to adjust to the screen size here. Okay, so I got the video here, and we can just take a look here and see what's going on here. So someone has a set of those glasses on. And you can see before each of those kicks that you can kind of see the red circle represents his gaze. And this guy's all over the place. Like, look at the ball, and then he's focused more on the downstream effect. And now just 2 weeks of that quiet eye training that you saw in the video, where you're trying to calm the brain, and you'll see that he'll focus first on the ball, the target, and then he'll look up. And you can see that the accuracy of that kick is much more where he wants it. So here's the target. He's looking where he wants to place it, and bang, right there. So not so erratic with his with the vision, where they're looking at. They're more focused. Now I'll just rewind it so you can see the beginning again. So the errors here are more focusing on the ball, trying to focus on the target, or not focusing on the target instead of focusing on the target. So that's a pretty significant improvement within 2 weeks. And it does take about 6 to 8 weeks for tissues to adapt. So, and someone that's already a novice or playing, the more you acquire skills, the less the effect you would in terms of the training effect you'll gain. And so in this case, that's a pretty significant improvement just in 2 weeks of not changing anything, but just how your hand-eye or your foot-eye or just your eye coordination is operating within this mechanism. So pretty powerful in how this stuff can work within that framework there. So the next slide I'm going to show you, we're going to look at now how that was like looking at how the visual affects the motor. And part of that visual is the perception. So we're also going to look at now how perception, both consciously and subconsciously, affects the input and can also drive motor behavior. So in a moment here, I'm going to pull up a slide, and it's going to have a bunch of circles in both column A, column B. And I'm going to give you 3 to 4 seconds, and I want you to just try to determine which side has more quantity. So ready? All right, so column A, column B, just kind of keep to yourself which we think, and we'll come back to it in a moment. But there's this aspect of this connectedness illusion that it causes people to either to misscale, but usually underestimate the number of targets that they see. So you saw on the column A, you saw a bunch of circles that were disconnected, and you saw in column B a couple circles that were connected. And we'll come back, and I'll give you time to actually count it to prove the math later. But I'm going to show you a series here of just visual distortions. Right, and in the end, those orange circles in the center are the same size. We look at here at these lines, and when we look at it, the lines are the same. And I don't know if you guys remember from a few years ago, maybe longer, is the dress blue and gold, or black and blue, and or gold and white, black and blue. And when we look here at these shades, these colors, these colored grays are exactly the same. And now when you look here, you look at this one, and they look vastly different. But if you try to put your finger right across here and look at the screen, and you block out the contrasting backgrounds here and the line here, and if you can't do it here, I done it for you, but it's exactly the same. So when we look at these visual aspects, that these things aren't necessarily reality. So what we see isn't always what is real. And what's fascinating is that your vision, when we look at these boxes, they're exactly the same. There's 22 here and 22 here, but since these are grouped together and they're a little bit more organized, they seem a little less in quantity. Now what's fascinating is that your conscious brain was making these decisions, right? Your subconscious brain is not fooled by these visual distortions. And so what they did is they did an experiment where they had these displays like what we had on the thing, left and right, and they wanted 2 things to happen. You kind of had to manually pick a side. So instead of you saying, counting here, you would just let your hand move A to B, which one was bigger or which one was less, depending upon the question. And You had about 400 milliseconds. So I gave you a little bit more time, but you had fractions of a second to determine. And what they found was that visually, if you were given enough time to think about it, most people, about 70-80% of the people, got the numbers wrong, right? They were fooled by the visual illusion. But if you let them manually do it and you didn't give them enough time and they just kind of had to more react to it, the inverse was true. About 80 to 70 to 80% of the people got it right. And so it fooled the eye, but not the hand. So something about the subconscious processing overridden by the conscious, but if you just kind of let things flow a little bit, you would be right more of the time. The researchers of this article had this great quote, and it was this here. It's as though as we have a semi-autonomous robot in our brain that plans and executes actions on our behalf with only the broadest of instructions from us. And if you remember from the slide that I started this lecture with, is that majority of the processing of the brain is subconscious, is outside of really our awareness. That 50 to 100 bits per second is which a conscious thought. The other remainder of that 11 trillion bits per second is all subconscious processes. So the question that you want to ask then is, if you're an athlete or you're a surgeon or you're on Jeopardy and you're in a spelling bee, do you want to be operating at a 50 to 100 bits per second, or do you want to be operating 11 trillion bits per second? And that's in fact where a lot of the sports psychology, sports performance, where a lot of Olympic and elite athletes are investing time in, is they're not really interested in the best supplements or the best workout plans. They want to know, how do we hack the brain so that we get the best performance out of it? And what's really interesting is where things are going is that this is not only applicable to physical performance, but also to mental performance. So your ability to retain information or perform successfully on a test or do well under pressure, giving a speech, giving a lecture, interviews, the mental processes that affect physical output affect the mental output as well. So they're one and the same. What's interesting, though, is that as you saw with the videos now and what we've been talking about, is that if you change focus and attention through vision, and the body reconfigures. So that's why a lot of the investment is in the mental aspect, is that your higher order aspect, you change the way you think, and all of a sudden, if you remember in that video that we saw with the golf, this guy, Alan Alda, never really golfed before, but his position, his posture, everything changed to maximize the environment. And so that's really what sport is trying to maximize biomechanics. And it does start at the visual cortex, right? That's where things begin. So really interesting. That quiet eye moment, the brain is taking in all that information, the environment, the task, the skill, everything that needs to happen, and it's making its formulations. There's argument that elite runners, before they even step foot out of the house onto the track, the body has already taken inventory, because the athlete is thinking of the task at hand. Has already taken inventory of what resources are available, and the time of that race is already set. So the brain, the conscious and subconscious, but more the subconscious, has huge influence over physical ability. And what's kind of happening here is that you have sensory information that's coming in, and it's not just your five senses, right? There's also like receptors in the joints and the mechanics that are giving information here to the brain, and the body has to kind of process all of this information. Some of the information can happen reflexively, and then you have upper cortical type processing. But all of this from the sensory input has to be processed at different levels of the brain. And this is really the equation that the body's trying to form, is that you have a particular movement that you're trying to do, a task. You have unique individual resources that are available, different on your experience, stress levels, your health, your status, fatigue, nutrition, and then you have your environment that has to do it in, right? Is it a high stress environment, low stress environment? Is it a new environment? Is it a known environment? And your body has to calculate that based on that. And so now we can see where these other 10,000 or the other 11 trillion bits a second is being utilized in that processing. And you're only aware of a little fraction of that, right? So it's pretty amazing. And what's neat then is in the future research is, are you just a personal trainer, strength coach, physical therapist, athlete that is focusing on just physical ability, or are you dealing with all the other mental stuff that's going on? The subconscious mind recognizes how the body needs to work for the task. It already knows what it needs to do. The mind wants to get organized, and the body wants to do it. What ends up happening is the conscious mind sometimes gets in the way. You overthink things. This is the principle of choking, not physically choking like on a chicken bone or a piece of meat, but choking like performance anxiety, where you were well prepared for an exam or well prepared for an event. You're ready to shoot a free throw, and you just choke, right? The amount of pressure gets to you. You start overthinking. You start doubting. Your conscious brain gets in the way of the subconscious mind. There's a tremendous amount of stress that happens if you start to overthink and trying to control. Some of it you can't control. You just have to kind of let go and go with the flow. And the next lecture that we have, we'll talk about stress and how this both positively and negatively affects our performance, both mental performance, academic performance, and physical performance in out of the gym. So what we look at is in this video was talking about this progression from novice to expert. And we pose a question to you real quick is what, in your words, makes someone a novice and what someone makes an expert? How do you become an expert? And it's usually, when we ask this question in a live lecture, it's usually some level of like time. So a novice is a beginner just starting out, whereas an expert has accrued a certain amount of clock hours, if you will, of the task at hand. How do you become an expert is you got to put in the time, right? 10,000 hours at a task to become an expert in that. You never really achieve a peak, right? There's always a certain amount of resources that has to go in, but you practice to get better. And I put a question mark there because what are you practicing, right? There's that adage that practice makes perfect, but practice just reinforces. So are you reinforcing bad behaviors or reinforcing good behaviors? That practice really is perfect practice makes perfect. But really what you're doing to practice in time is you are trying to move more of the conscious thought, surrendering that, so that becomes more subconscious. When you look at people that practice martial arts or people that practice dance routines, they routine, go over and over again, because when it counts in high stress situations like competition or your life is in danger, you want to be able to execute a task without having to think. Because what happens unanimously with humans is that in high stress environments, you get tunnel vision, you forget, you get put on the spot. And anyone that has a fear of public speaking, that has rehearsed their speech over and over again, they get up to speak, they drop the bomb, right? Or drop the ball. So, but the goal for all physical activity, mental activity, is to move more and more of it into the subconscious mind, and then learn how to turn your conscious mind off, or not so much turn it off, focus and redirect it on other things. And there's a process in learning, stages of learning, that goes from this conscious and unconscious, and competent versus incompetent. And it's the stages of learning. And there's 4 stages, 3 that are associated with motor control and learning, but I include all 4 with this learning aspect, is that most people start off as unconsciously incompetent, right? They have no idea that they don't know, right? So they're ignorant to the fact that they have no idea what they're talking about or doing or whatever. But most people start here at 2, right? The cognitive stage. They look at a task, they say, hey, I see someone doing that, I want to do that. Or, hey, I don't know anything about this task, I want to learn about it, this subject. So you're consciously incompetent. You're aware of your limitations and shortcomings, right? And then you start your research. You're like, okay, well, I want to learn how to do a double backflip off a diving board, or I want to learn more about genetics, or I want to learn more about recipes, right? So you start to look and you read and you practice and you become consciously competent. You have to put a lot of effort into it to perform at least somewhat poorly. And then people spend a lot of time in this associative stage where they become better. They still have to think about it. They're aware. They're thinking about their task. But the goal is to get into this autonomous stage where you're unconsciously competent, where you now are able to execute these tasks without really having to think about it. You can open up your pantry, put together some ingredients, and you didn't even have to check the recipe book. You just kind of did it, right? And then you made, like, let's say you made a French onion dip from scratch. Now let's just do ranch and let's play around with it and do it. Now you're experimenting and you're now in the creative stage. So this is the level that we want to get at. Or you're a gymnast and you're like, yeah, I could do a double backflip, but let's add a twist to it. And you don't really have to be taught it. You kind of already know it and you're confident enough to do it. You just do it. So this is the stage of what we're looking at. And this is what it looks like visually. And what you're really trying to do ultimately is get more of that conscious thinking and drive it down into the subconscious mind. That's the game plan, right? So you're going from this cognitive stage to that associative stage, that practice, that refinement of movement, and then now you can focus on performance. And that's that happens both with physical activity and with mental activity, right? In terms of like say you're studying for a biology exam or anatomy exam or kinesiology exam, you are thinking a lot about the material, new words, new terminology, you don't quite get it, and all of a sudden a light bulb snaps on and you got it, and now you can start doing stuff with that data. So that's the kind of the map that we're looking at. When we look at learning outcomes for both motor and aspect, these kind of are the areas these are the criteria that we look at for learning outcomes. Looking at like knowledge of concepts, do you understand like basic components, control and coordination? As you start to see this move from cognitive stage to this autonomous stage, you're going to see an improvement in movement efficiency. You're going to see an improvement in understanding why you're doing what you're doing. Instead of just doing it, you're like, oh, that's why I'm doing this, or that's why I'm adding this ingredient, or that's why I'm putting this word in there. Your attention, your focus goes more from the task itself, more to the environment, right? So you don't have to really think about doing a squat or throwing a football or whatever you're doing. You're more looking at your opponent now or looking at intensification. And then you start to become more independent in your error detection. You can recognize when something was wrong and correct it on your own without having to have a coach or a mentor. So I kind of went through this. This is like the feedback, the practice, the knowledge of results. Those are the kind of the terms that are consistent with motor learning, that through practice and feedback and knowledge of your outcomes, right? Did you do it? Did you do it or not? You're able to get these improvements over time. And that's how this happens. It's not just practice, but it's practice, it's feedback, it's thoughtfulness, it's intention. And your goal is to get, again, more of the conscious thinking gone so that you can free that up for strategizing and interpretation and get more of those tasks down into the subconscious brain. So the question then becomes have experts learned more than novices? And that may or may be true, right? They might have learned more, but they just don't have to think as much. Do experts perform better than novices? We would say generally is the case. And then, so yes for that one, yes for that one. And then this last question here, does increased performance mean increased learning? And this answer is an actual no. And what happens is that people misconstrue performance for learning, right? And let me give you the definitions here, and then we'll talk about how most people have kind of experienced this. Is learning refers to the permanent changes in knowledge or behavior. So how well do you know that task, or how well do you know that information? Performance is, did you do well enough on an exam, or were there a moment in time where you performed well? You got a lucky shot. Or how we most look at it is, how many people have crammed for an exam, studied like 2 or 3 nights before, have performed well on the exam, but then if you were given that same exam like 2 weeks later, how do you think you would do, right? And if you would bomb it, which I would, right, if I just kind of crammed it in there, I performed well, but I learned nothing, right? And we in education, academia, and even in sports, we can misconstrue performance for learning. And the focus should be learning. You want to know the task well. The problem is that it takes a little bit longer time. If you didn't cram for the exam, the alternative would be that like maybe 2 or 3 weeks beforehand, you started that practice cycle, right? The practice, the feedback, the knowledge of results, and you started driving more into the subconscious mind. And the better you retain in the subconscious mind, the slower it takes to get there, but the more resilient it is to forgetfulness, memory, and stress, right? High anxiety. So we confuse that a lot. In golf, we'll use this example, is that sometimes people will, if they're practicing with their golf clubs, they perform really well with their driver, and so they practice that one over and over again, giving the thought that they perform well, but then they don't know how to really adapt that or use other clubs, or that swing mechanics needs to change because the way you putt and the way you drive and the way you hit a wedge are all different, right? And that can be applied to any of the sporting environments. So we look at learning, we look at performance. Learning is the goal, but there's a lot of things that can affect performance. And I talked about it to you a little bit. We talked about stress, pressure, anxiety. Can what you know be altered by something else when using it? Right? And the answer is yes, right? So like you might know that answer. How many times have you taken an exam and you look back and you get the exam back and you're like, man, I really knew that one. And you just had a brain fart at that time, right? because of that stress environment, whatever it is. And testing situations are high stress, no matter how comfortable someone is. But the environment, your physiological response, your state, your mental how tired you are, what you ate before, how well or unwell prepared you are, your stress, your thinking, all these can affect your performance, which then can apply or change how your execution of what you've learned. So when we look at performance, we look at this as a performance versus arousal. And we look at that arousal has an optimal level, right? And that you can be too low aroused. This is why people listen to aggressive music when they're working out and not elevator or smooth jazz. At least I hope not, because you're going to be more in this more relaxed, calm state. And that's why during periods of like massage or down regulation or self-care recovery, you're listening to soothing music and naturescapes, and because you want to lower the arousal level to hear. But you wouldn't use that same music if you're trying to win a war or win a fight, right? You're going to have... With that said, though, is that there's this whole Goldilocks principle that exists within fitness, and not too soft, not too hard, but just right. And the way this interprets is that the highest level of performance are at these optimal level of arousal, where it's just enough arousal, so you're increasing activity, you get hormone levels going, you're ready to go, you kind of got that like competitive grit, but not so high where you start to get into stress and anxiety. And it is a downward spiral. And when you ask them, a lot of performing athletes, like, why are they stressed? They usually interpret panic or anxiety or stress as excitement. And instead of this energy here, which is not good or bad, but this energy here, instead of it overwhelming the individual, it's actually fueling the individual for that optimal aspect. And that does take some level of training and preparation. So how you approach your lectures, how you approach your workouts, how you approach your studies, how you approach your work, your training, everything operates on this arousal scale, right? Are you excited about it? Are you too excited about it? Are you nervous about it? Or is it just bore you to death, right? And that's going to affect your performance. So there's certain things that you can do, certain tricks you can do to kind of climb the level and also backpedal a little bit. So what we're going to do in class, we normally do a lab in class, but I'm going to have you guys do this on your own. And it does take a little bit of skill, not skill, a little setup actually. But if you can print this, you're going to print this star and you are going to trace it, right? And you're not going to use your left hand or your right hand. You're going to use your dominant arm and you're going to try to fill in the lines, right? And it's going to be pretty easy, except for the fact that you're going to be doing this in a mirror. So you're either going to have a mirror on your table or on the wall, and I'll have another video that kind of shows your setup. But you're going to learn a new task, something that's not new to you per se, but new in terms of a new motor environment. And you're going to change the different parameters, and you're going to see how many errors you make, and you're going to time, and you're going to look at your learning process. You're also going to look and see how your body responds to stress and look at your performance. And the way this works, like I said, I'll have another video that supports this, but you're going to, in the mirror, not by looking at this, you're going to do your drawing here, and you're going to have your start point and your end point, and your lines are going to look like this, right? They're not going to look like these straight lines. And every time your line crosses or touches the line itself, it's like the game operation. A buzzer would go off. You just count that as an error. So a very simple experiment. And I'll have you guys do that. Look at the video, and then we'll circle back on part 2 of this lecture.